We're going to look at motion in a circle, otherwise known as circular motion. Now, here we have circular motion. There are two things to notice about circular motion. Number one, it's in a circle. Two, it's motion. The interesting thing about the motion is that the motion is basically fairly constant in terms of the speed. This blue ball is going around the red ball. The object is moving in a circle at a constant speed. However, it is accelerating. How is it accelerating if the speed is constant? Look at here, then here, then here, and then carry on. If you notice that even though the speed is constant, the direction is changing, and this is why it's accelerating. Now you see that even though the speed is constant, the direction is changing. And if the direction is changing, by definition, the velocity is changing, because velocity is a vector, and which means it has direction. Now, if the velocity is changing, we know that the acceleration is a change of velocity. So the change of velocity, which is v minus u divided by t, gives us the acceleration. How can we find v minus u if they're in different directions? We can do this by vector addition. V, which is the final velocity, minus the initial velocity, so we basically need to go from here to here, gives us the resultant change in velocity. So the direction of the change of velocity is in this direction, and because the acceleration is the rate of change of velocity, this also gives the direction of the acceleration. So the acceleration is always towards the center of the circle, and that's why it's called the centripetal acceleration. So, what do we know about this? First, we have constant speed, but since there's a change of direction, there's also a change of velocity. And velocity is a vector, so it means that a change of velocity means there will be acceleration. This is called the centripetal acceleration towards the center of the circle. Now, there's a formula for this, which is A is equal to v squared divided by r, where v is the speed and r is the radius of the circle, or the radius of curvature. So we have an example. On a roller coaster like this one, the car loops the loop in around 2 seconds, and the radius of curvature is 5 meters. Find the centripetal acceleration. Well, first of all, we need to find the speed. We know that it does the loop, which is 2 pi r in 2 seconds, and the velocity is distance divided by time. So and we know the radius is 5 meters, we're told that. The speed is 2 pi r divided by t. Secondly, the acceleration is v squared over r, and you know that r is equal to 5 meters. So it's 15.7 squared divided by 5 gives us an acceleration of 49 meters per second squared, which is roughly 5g. And that's why circular motion is acceleration.